Prove that for all sets A and B minus A equals B intersection A complement. Now, to prove that two sets are equal to each other, we have to first show that everything in the first set must also be in the second set, and we need to show that everything in the second set must also be in the first set. Put another way, we must show that B minus A is a subset of B intersection A complement, and we have to show that B intersection A complement is a subset of B minus A. Now, the way we prove the first part is that we have to start with an arbitrary element, which I'll call lowercase x. And x is an element of the first set. We must show that x is also an element of B intersection A complement. By doing so, it is the arbitrariness of x, the fact that we don't know what x is, that proves that this must be true for all elements in B minus A. So this is how we prove a universal quantifier. So now we have this assumption that x is in B minus A, and we want to show that x is in B intersection A complement. What we can do is we can unpack what it means for an element to be in B minus A. We could say then by definition that x is an element of B and x is not an element of A. Well, we want to show that x is an element of B intersection A complement, which means that we want to show that x is an element of B, and we want to show that x is an element of A complement. We already showed that x is an element of B here. Now we need to show that x is an element of A complement. To get there, we can use the fact that x is not an element of A. By definition, for an element to be in the complement of a set, then that just means that that element is not in the set. So this means then that x is an element of B and x is an element of A complement. But now we can apply the definition of intersection. For an element to be in the intersection of two sets, that means that element must be in both of those sets, which x is in B and x is in A complement. So this means then that x is in B intersection A complement. That's the first part of the proof. Now let's prove the second part of the proof, which is that B intersection A complement is a subset of B minus A. Now, this proof is going to look exactly like the previous proof, but just in reverse order. So we'll start with an arbitrary element from B intersection A complement this time, and then unpack that definition. And then we can unpack the definition of A complement to say then that x is in B and x is not in A, and this is what it means to be in B minus A. And so we've proven 1 and 2 here, which means that these two sets really are equal. Everything in the first set is in the second set, and everything in the second set is in the first set. Thanks, everyone, and I'll see you in the next video.